Next, we're going to look at compositions of translations, and this is when you perform more than one translation at a time. So we might move to the left and then to the right, or move up and up again. In this first example, we have the point 3, 3, so I'll plot 3, 3 here first, which is right here, and that's A, and it's moved 5 units to the left and 2 units down, and that new point would be A prime. And then from there, A prime is moved 1 unit to the right and 5 units up, and that's called A double prime. What I want to know are the coordinates of A double prime. So this would mean that I just want to know what A double prime is, so the point after both of the translations are performed. So if I use our shortcuts here, we know that we start at 3, 3. And then it's moved 5 units to the left. So that means that we are subtracting 5 from the x, and 2 units down means that you're subtracting 2 from the y. So that new point would be A prime. So what's neat about this, though, is I'm not interested in A prime, I want to know A double prime, and I actually can combine these translations together. So if we check here, when I continue, A prime is moved 1 to the right, so that would mean I would take the x and I would add 1 to it, and then it's 5 units up, so we would have to add 5 to the y. So when I go here and I write down what we start with, so the x coordinate was 3, I'm going to put both x translations together. So we'll do that here in green. So I need to subtract 5, and I also need to add 1. So going 5 to the left and 1 to the right would be the same as just going 4 to the left. For the y's, same thing, so y was 3, and in blue here we need to subtract 2 from that y and then add 5 to it as well. So A double prime is really located at 3 minus 5 is -2. -2 plus 1 is -1. 3 minus 2 is 1, and 1 plus 5 is 6. So this should be where the new point is. I can check that over here. So if we take A, which is in red, and we'll go 5 units to the left, 1, 2, 3, 4, 5, 2 units down, this would be A prime. So that's at -2, 1, and you don't see that anywhere in my work because I didn't write anything down for A prime. But then that point is moved 1 unit to the right and 5 units up, which is right here. And this is A double prime. And what is that ordered pair? That is -1, 6, which is the same thing we got, so I know that we're correct. For our second example, triangle ABC is moved 3 units to the right and 4 units down. The resulting image is triangle A prime, B prime, C prime. The figure is then moved 6 units to the left and 2 units down, and that resulting image is triangle A double prime, B double prime, C double prime. What are the coordinates of triangle A double prime, B double prime, C double prime? So I've already written down the coordinates that describe the pre-image, and if we go through here and we put our translations together, we'll get our new point. So up here we have that we went 3 units to the right. So to the right means that you're adding to the x. 4 units down means that you're subtracting from the y, so that takes care of the first transformation. Then we go 6 units to the left, so we're subtracting from the x, and 2 units down, subtracting from the y. So for A, we take -5, and then I can put with it the 2 translations. So to the right 3 means add 3 to that, and then we went left 6, so subtract 6. And then the y coordinate was 1, and its movement was down 4 first, so -4, and then down 2, so -2. So this new point, which I'll just have to write down here, A double prime, would be located at -5 plus 3 is -2, -2 minus 6 is -8, 1 minus 4 is -3, -3 minus 2 is -5. So there's A double prime. B, we can do the same thing. So we have -2.5. We will add 3 and subtract 6. And then for the y's, start at 7, and we will subtract 4 and subtract 2. So that gives us that B double prime would be located at negative 2.5 plus 3 is 0.5, and 0.5 minus 6 is negative 5.5. 7 minus 4 is 3, and 3 minus 2 is 1. For C prime, or C double prime, we have 0. We have to add 3 and subtract 6. And then for 1, we have to subtract 4 and subtract 2. And so C double prime would be located at negative 3, negative 5. And then there are your points. Again, if I wanted to check, I could move A, B, and C up here from the original graph to make sure that they were correct, but for now I'm just going to rely on the rules.